Welcome to Study Loop.
Okay, to answer this question of molar solubility of barium fluoride, at first we need to construct our plan according to some task. What we will do first, at first we will write the balance chemical equation. The balance chemical equation first for ourselves. Then we will figure out what is the solubility product of that, the KSP. After that, we will figure out if there is any common ion effect. I will explain it what it is. Common ion effect for that. Then we will figure out our ice table. We will make a table that is named ice. I will explain again what is this ice table, and in this way, by following this step, we will be able to figure out the molar solubility. So our solute here is barium fluoride. So let me write the balanced chemical equation first. Barium fluoride here. It goes like that. So here is our balanced chemical equation. So it will dissociate into barium 2 plus ion, obviously in aqueous solution, plus 2 fluorine negative ion. Here it is, and again it should be in aqueous solution. Now we need to figure out the solubility product of this reaction. The solubility product here we can figure it out from any general chemistry textbook, and for this reaction it is 2.45 times 10 to the power minus 5. Now the solution, so liquid we are using here at first is water, so we need to figure out if there is any common ion between barium fluoride and water. So there is not. If there is no common ion effect, we can move forward to construct our ice table. Let me write it in green. So I C E. So this is our ice table. Let me draw the table first. So here goes our ice table. And we will place our ions here. So we can select, okay, let me write it down. So here it should be barium 2 plus, and here it should be our fluorine. So I stands for initial. So before any reaction, what is the concentration of barium ion here? So it is 0, right? So we will put 0 here, and it's the same is true for fluorine as well. So fluorine is 0. Now when the reaction begins, the concentration of the ion, they will change, but we don't know at this moment how much it has changed, but we know some part has changed. So here is some change, how much it has changed. And for fluorine, we need to remember one thing, that when this barium fluoride dissolves in water, then for every mole of barium fluoride will produce 1 mole of barium 2 plus ion and 2 mole of fluorine minus. So we need to write here 2. This 2 is coming from here. Okay, I need to put S here. So here is our 2S. Now, what is the concentration at equilibrium? It stands for equilibrium here. So we need to add them up. So here it should be S, here it should be 2S. And there we can put a plus there. And our solubility product We can also write it as the product of the concentration of the ions. So here it should be barium 2 plus times the concentration of fluorine minus. But as there is a 2 here, we need to get a power of 2 there. So now if we consider the Ksp of this reaction or dissociation, then we will put the concentration of barium 2 plus here, that is S at equilibrium. So we will put S times the concentration of fluorine, that is 2S. But we need to square them up because of this square. And this value should be equal to this value here. So from there, we can calculate S. So what is here? It should be 4S cube. That should be the same value. So if we do the calculation here, then we will find S is equals 1.82 times 10 to the power minus 2. So this S is our molar solubility. The S is actually the amount how much barium and fluoride has been dissociated in water. So the next thing is, the next solution is 0.1 molar barium nitrate. Instead of water, now we are going to use barium nitrate here. So at first, our balanced chemical equation, the chemical equation for barium fluoride will be the same, the Ksp will be the same, this one. But now we need to consider the common ion effect, because now we have something in common, that is barium. So now we can make our I stable again. Oops. Let me write it here. So here we are going to make our I stable again. So our initial concentration of barium, now as we have 0.1 molar barium nitrate present, so now it is not 0, it should be 0.1 molar, but the fluorine is again 0. And for the changed one, again it should be plus S, and for fluorine it should be plus 2S. Again, this 2 is coming from here, this reaction. And at equilibrium, if we add them up, we will get 0.1 plus S, and for here it should be 2S. So if I put this value here in this equation, then we will find that now, so for S barium concentration, the barium concentration is now 0.1 plus S times the concentration of fluorine, it is 2S, but squared. Now from this dissociation constant, we can see that the dissociation is very less. It's very little amount of barium fluoride is dissociating. So we can take an approximation that this S will be negligible with respect to 0.1. So what we are going to do, we are going to neglect this S. So our equation will be then 0.1 times 4 S square, and this thing will be equal to this value. And if we do the math again, then we will find that the value of S will be 7.82 times 10 to the power minus 3. Okay, so the third one is 0.15 molar. Okay, let me also say that the unit of this molar solubility should be molar, the M. Now we can move forward to the third one. Again, the balanced chemical reaction will be the same and the KSP will be the same, but we need to change our initial, let me delete this, and equilibrium concentration. Okay, here. So now we have a common ion effect, and now the common thing is fluorine minus. So we will put the initial concentration of fluorine here, that is 0.15, and for barium it is 0. So at equilibrium it will be S, and here it will be 0.15 plus 2S. So what we are doing here, we are adding these two columns or rows. Okay. And if we do the math here, let me delete it. So if we do the math here, so the concentration of barium 2 plus, it is S times the concentration of fluorine, that is 0.15 plus 2S. And once again, as this dissociation constant or the solubility product constant is very small, so we can take an approximation that this S value will be very small with respect to 0.15 value. So again, we will ignore it. So here it should be, okay, I forgot a square here, so there should be a square. Yes, there should be a square here. Let me put that square, and there should not be any plus. Okay, let me write it again. So here is my bracket and here is my square. So from here we will find it. It should be 0.0225 S, and this value is equal to this value again. And if we solve it for S, then the value of our S will be 1.08 times 10 to the power minus 3 molar. So in this three problem, the first one don't have any common ion effect, but the rest two has common ion effect. And this is the procedure we can solve the problems regarding molar solubility. Thank you.